This is lesson 1-4, patterns and functions. A function is a relationship that assigns exactly one output value for each input value. A function rule is an equation that describes a functional relationship. So let's look at some of these. Here are some function rules. C equals P plus 600 P. That's a function rule. Also, y equals negative 1/2 x plus 7 is a function rule. Also, if you've ever seen f of x equals negative, or you know what, let's make it positive, 3x minus 2. All of these are examples of function rules. There are also function rules such as y equals simply 2x, and maybe that's it. That's the whole function rule. And so it says a function is a relationship that assigns exactly one output value for each input value. The output and input are very important. So the input is the number that you would put in for x. For instance, maybe we would input the number 4. So y equals 2 times 4. Our input value is 4, and when we input 4, we output 8. So y equals 8 would be our output. And any number we plug in for x would be our input, and then we would get out a certain number for y. Example 1, writing a function rule. Suppose you are buying apples from a vending machine. I don't know why, but you're buying apples. Use the table to write a function rule. So we want to see if we can find the pattern in this table. So as I'm looking at the table, I think, okay, how can I get from 1 to 35 cents? Well, one way would be to add 34 cents, but we have to make sure that's going to work every time, or add 3,400. So 2 plus 3,400 does not equal 70 cents, so that doesn't work. Let me get rid of that. Let's try something else. So instead of adding, maybe I could multiply times 35 cents. So 1 times 3,500 does equal 3,500. 2 times 3,500 does equal 7 tenths. 3 times 3,500 does equal 1 and 500. And 4 times 3,500 does equal 1 and 4 tenths. So this actually does work, and I found the pattern. Now that I found the pattern, the function rule is easy. Come up with a variable for number of apples, maybe n. And what are we doing to n? We're multiplying it times 35 cents. And then that gave us what was in our bottom column, cost, so C. And then we'll just rewrite it to look a little more sophisticated. Instead of this times sign, I can just write 3,500 n, and that's the same as n times 3,500 equals C, or we can rewrite it C equals 3,500 n. Either one of these is fine. Really, all three are correct. These just look a little better. Let's look at another one. Again, we're trying to find the pattern in the table. How do you get from 1 to 60, 2 to 120, 3 to 180, and so on? So the first thing you might try is, again, to add 59, but that doesn't work on the second one. So let's instead multiply. 1 times 60 is 60. 2 times 60 is 120. 3 times 60 is 180. And 4 times 60 is 240. Now that we found the pattern, we're going to write our function rule by giving our top column a variable, ours h, and what did we do to h? We multiplied it times 60, and then that gave us the bottom column, total miles, which we can use T or M for. And then again, I'll rewrite it to look a little more sophisticated. H times 60 is 60H equals T, and we can write it in the reverse, T equals 60H. Either one of those are correct. So let's look at our next example. Example 2, this is just a little more complicated function rule, but we're still writing function rules. So it says to make a 2-story house by adding 1 toothpick that goes from side to side. What they mean is, if you were building houses like this, now you're going to build them like this. That way you get 7. 1, 2, 3, 4, 5, 6, 7. So 7 toothpicks to build one house. If you're building 2 houses, you get to use that toothpick right here again for the other one. So it's 1, 2, 3, 4, 5, 6, 7 here, 8, 9, 10, 11, 12, 13 toothpicks there. So you save a toothpick because they're sharing that one right there. But again, we're just trying to find the pattern in the table. So don't get bogged down by all these words up here. All we want to do is find the pattern in the table. So how do you get from 1 to 7? Well, we could add 6, but that wouldn't work here. We could times by 7, but that doesn't work here either. So now what are we going to do? And this is where most people would just sit and guess and check. But there's actually a better, quicker way than sitting and guessing and checking. You can look and see what's the difference between the numbers on the bottom row. 7 plus 6 is 13. 13 plus 6 is 19. 19 plus 6 is 25. So the difference is 6. You take that difference and you multiply by it. 1 times 6, and then we have to add 1, gives us 7. Let's try it over here. So again, we're multiplying times 6 because that was the difference, and then adding 1. Got to do the same thing every time. 2 times 6 is 12 plus 1 is 13, so it works there. Let's try it again. 3 times 6 is 18 plus 1 is 19. 4 times 6 is 24 plus 1 is 25, so it works every time. And again, I knew I was multiplying times 6 because that was the difference down here. You could have sat here and said, okay, let me try 1 times 5 plus 2. Well, 2 times 5 is 10 plus 2 is 12. That doesn't work. Let me try another one. And you could sit here all day and check 1 times 2, 1 times 3, 1 times 4, 1 times 5 until you found it. Or you can use this little shortcut. So let's write our function rule. Again, go to the end. Number of houses, you can use N or H. And what did we do to it? Times 6 plus 1 equals our total 2, 6, or T, and then we'll rewrite it. N times 6 is rewritten as 6N plus 1 equals T, or T equals 6N plus 1. Either one of those. So let's look at another one of those. Again, you can sit and guess and check. 1 times 5 doesn't work here. 1 plus 4 doesn't work here. So we know it's going to be a two-stepper. So find the difference. 5 plus 3, 8 plus 3, 11 plus 3. So since the difference is 3, I know I'm multiplying times 3. And then 1 times 3 is 3, so I have to add 2 to that. 1 times 3 is 3 plus 2 is 5. Let's see if it works here. 2 times 3 is 6 plus 2 is 8. 3 times 3 is 9 plus 2 is 11. 4 times 3 is 12 plus 2 is 14. So if you'll find the difference in the bottom row, you'll know what you're multiplying by. And then you just have to figure out what to add. So get to the end. Let's write our function rule. Input x, so x times 3 plus 2 equals, I just took all this, output y, so y. And then we can simplify it. X times 3 is simply 3x plus 2 equals y, or y equals 3x plus 2. Those are the exact same thing. Dependent variable and independent variable. So we're adding some more stuff here. Let's go back and let's look at this. This is our input x, output y. So this top column, or row in this case, this top row is your input x. If we were looking at a vertical table, then the left one would always be your x, and the right one would always be your y. X is always first. X always comes first. So if it's in a vertical table, then it's left to right. If it's in a horizontal table, it's on top. X is always first. So X is your input. And now we're going to add something to that. X is input, Y is output, and now we're adding dependent and independent variables. The dependent variable depends on the value of the independent variable. The independent variable obviously doesn't depend on anything. So our X, remember, is our input. It's also your independent variable. This is just like in science where you have independent and dependent variables. You know, the independent is completely independent of anything else, but the dependent variable depends on the independent variable, and if the independent variable changes, so does the dependent variable. And then we have Y is your output, and also it's the dependent. Y is dependent on X. So let's look at how that affects us. In example 3, we're identifying independent and dependent quantities. Suppose you want to find out how much gas a trip will take in a car that uses 1 gallon of gas to go about 18 miles. What are the independent quantity and the dependent quantity for this situation? So all they're asking us to do is identify the independent and the dependent quantity. Well, in order to do that, I first need to figure out what are the two things that I'm comparing. Let's see, we're trying to figure out how much gas, so that would be gallons of gas, used and miles in our trip. So we want to know how much gas we're going to use in our trip, and it's 1 gallon of gas for 18 miles. So we're obviously talking about miles in the trip. So our two things are gallons of gas and miles in the trip. Then you have to ask yourself, which one depends on what? Well, if you're talking about miles in the trip, is that going to change depending on how many gallons of gas you have? No, it's not going to change. The miles in your trip is whatever it is. If you're going to Austin, it's 400 miles. No matter how many gallons of gas you have, the Austin is not going to change how far away it is. And something else you can do is ask yourself, do the gallons of gas, and we can say gallons of gas used, do the gallons of gas used depend on the miles in the trip, or do the miles in the trip depend on the gallons of gas used? Well, it doesn't make sense to say that the miles in my trip is going to depend on the gallons of gas used. That makes no sense. But it does make sense to say that the gallons of gas depends on how many miles we go. The more miles you go, the more gas you use. So the gallons of gas used is dependent on how long your trip is. The longer your trip, the more gas you're using. So the miles in your trip are independent of the gallons of gas used, because however long your trip is however long it is. That's not changing. But the gallons of gas will change. It'll depend on how long your trip is. So let's look at another one. The cooking time for an unstuffed turkey is about 20 minutes per pound. What are the independent quantity and dependent quantity for this situation? Again, we're trying to find independent and dependent. So first we need to identify what are our two things. Well, we have cooking time. The cooking time for an unstuffed turkey is about 20 minutes per pound. So we're obviously talking about not only how long it takes to cook, but also how much the turkey weighs. So we have cooking time and weight of turkey. So again, think about it in real life terms. When you go to the store, whatever turkey you get, the turkey you get. And however much it weighs is going to determine how long you have to cook it. So the cooking time totally depends on how much your turkey weighs. The more your turkey weighs, the longer it's going to take to cook. Your cooking time is completely dependent on how much your turkey weighs. But you're not going to choose a turkey based on the time it takes to cook. You wouldn't just sit in the store and try and figure out how long it's going to take you, although I'm sure you want to know, but you're going to get a turkey based on how big you need it to be to feed everybody who's coming to Thanksgiving. So the weight of the turkey is totally independent. The cooking time depends on how much your turkey weighs. Domain and range. Domain is the possible values for the input or the independent variable. And range is the possible values for the output or the dependent variable. So you can see then that X goes with input, independent, and domain. And Y goes with output, dependent, and range. So let's look back at that problem we just did and see if we can find the domain and range for that problem. Again, remember, domain is your independent. Domain goes with independent. So if we're going to find our domain, then that would be the weight of the turkey. How much does the turkey weigh? Well, let me give you some parameters here. Let's say that the turkey weighs between 10 and 15 pounds. So that's set. It can't change. I've given you the weight of the turkey. So your domain then are your possible independent values, the possible values for your independent variable. And the weight of the turkey is 10 to 15 pounds. That's all it can be. It can't be 9 pounds, can't be 16. It's somewhere between 10 and 15. So there's your domain. And sometimes it's just given to you easy like that. Sometimes your range will just be given to you. But in this case, we need to find our range. And remember, range goes with dependent, so that's our cooking time. How long is it going to take us to cook the turkey? Well, it takes 20 minutes per pound. So if our turkey was 10 pounds, how long would it take? 20 minutes per pound, 20 times 10, 200 minutes. And then what if our turkey was the heaviest? If it was 15 pounds, 15 times 20 would be 300 minutes. So you just have to multiply to figure out your range. Let's try that on another problem. Ken burns 425 calories per hour when he bikes. He bikes from 3 to 7 hours each weekend. Identify the independent and dependent quantities for this situation and find reasonable domain and range values. So we have two things to do, two tasks. We have to identify the independent and dependent quantities. Then we have to define the domain and range for this situation. So first I'll start by figuring out what are my two things. We're talking about the hours that he rides his bike and the calories that he burns. Those are my two things, calories burned and hours biked. Okay, so again, we have to determine independent and dependent. Which one depends on the other? Do the number of hours you bike depend on the calories you burn, or the number of calories you burn depend on the number of hours you bike? It's obviously the second one, that the calories have to depend, your calories burned are dependent on how many hours you bike. This is one of those things where the more you practice, the easier it gets and makes more sense the more you practice it. The hours he bikes wouldn't depend on the calories he burns. It doesn't make any sense. You decide, okay, I'm going on a bike ride, and either you determine I'm going to go this many miles, or I'm going to bike for this many hours, or I'm going to bike till I'm tired. So the calories he burns totally depends on how many hours he bikes. We generally don't get outside on a bike and say, okay, I'm going to burn this many calories, because usually we don't know how many calories we're burning. In this case, he does, though, 425 calories per hour. So now that we know dependent and independent, let's find domain and range. Remember that domain is the set of values for your independent variables, and our independent variables hours biked. Well, we're in luck. They told us he bikes from 3 to 7, so they have given us our domain, 3 to 7 hours. Now all we have to do is find our range. Well, the range is, goes with dependent, so it's calories burned. How many calories does he burn? 425 calories per hour. So first we have to figure out how many will he burn if he goes 3 hours. So multiply 425 times 3, 1275, and then 425 times 7, which gives you 2,975. So he'll burn between 1,275 and 2,975 calories while he's biking. Okay, well, just if you'll remember, X input independent domain, Y output dependent range, then you should do fine on this lesson.